Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 9 of the daily code challenge for the February month, and we have a very good question in front of us. It's question 368, largest divisible subset. So we'll go through this question, but again I would like to mention that see, it's about all you are doing is how to solve questions, that you're it's all about developing that mindset, right? Yesterday I could not post the solution within the time frame because I was involved in some office work, but as you might have seen in my channel, I have already posted the solution. Actually I solved it, but I did not get time to create the video, so I already posted this solution. Okay, so see what the idea here is, please do give it a try before seeing any solution. That is definitely a very good practice, let me tell you that. See, video solutions, all these things are for your help, but they should be used only after you have given it a try. See, some kind, for example, this is a medium kind of question, and let's say some even harder question comes, you will definitely not understand if you directly see the video. If you have tried the question once or twice, then definitely you will have that understanding of where your case is failing, or know which part you are not able to code. Then you will be able to grasp the solution in a better way. So having said that, let us go to this question. I felt this is a really good question to understand the DP concept, dynamic programming concept, and let us see what it is. So as you can see in the input, we are given a simple array of a simple integer array, and in the output also we'll have to return an integer array. Okay. So let's see what the question is. Given a set of distinct positive integers, so one thing is very clear: they are all distinct. Okay, they will not be same. Given a set of distinct positive integer nums, return the largest subset. Okay, we'll have to return a subset of it. Return the largest subset answer such that every pair answer y comma answer of j of elements in the subset satisfies this. Okay, you can go through it, but what they are trying to say is that let us say this is our answer subset. So what here is, take any, okay, let me come to this. Let us say this is the answer subset. So what will happen here is, pick any two integers among them, any two. Okay, let us say they are I comma j. Okay, so either I should divide j or j should divide I. Either of these two should be satisfied, only then this will be a correct answer subset. Okay, that is one correction. That is what they are trying to mention here. If I pick any two integers in my answer subset, okay, then either the I should divide j or the j should divide I. Either of them. Okay, remember they are or, it's mentioned as or. Okay, not as and. Remember, if they had mentioned as and, then the total question would have changed. Can you quickly tell me what would have been the answer if it would have been and? See, try to understand which numbers at a comma b is there. A should divide b and b should divide a. What can be the numbers? Obviously, the number should be same. That is all two can, like for example, two like that. Twos will divide itself in either way, right? Similarly, all threes, all ones, something like that. But this question says that or. Okay, that means either I should divide j or the j should divide I. One thing you would might have understood is that, see, suppose I is a bigger number, let us say, then obviously, and let us say j is a smaller number, so obviously j divided by I is not going to be appropriate one. Okay, because j is the smaller one, I is a bigger one, so obviously it should have be the other way, that is I divided by j. So that is one hint to it what you can do. But yeah, that is the question. I hope you understand the question. This is the answer, question given to us. Among them we have to choose a subset such that any two elements in that subset divides, divide this, satisfy this condition, that is either I should divide j or j should divide I. That is the basic idea. And they have also mentioned that if there are multiple solutions possible, return any of them. So let us quickly go through the example cases and let us try to understand what they're doing. In this case, as you can see, if I pick these two, then also it satisfies. For example, 1 will divide 2. Okay. Similarly, 1 will divide 3 also. So 1 and 3 is also a valid solution. So one thing is very clear. Whatever be the set, the maximum length of the set is going to be 2. Okay. One thing is clear. So as I have mentioned, either it's 1 comma 2 or 1 comma 3. That is also a valid answer. Okay. Now come to the second example, 1, 2, 4, and 8. As you can see, if you go from left to right, 1 will divide 2, 2 will divide 4, 4 will divide 8. Okay, that is the basic idea behind it. Okay, so yeah, as you can see, the whole thing is the answer. Now let me tell you one thing, just try to understand this fact. Let us say that we know that 4 is getting divided by 2. Okay, okay, let me start it from the beginning. Let us say I'm at 2. Okay, 2 is getting divided by 1. Okay, one thing is very clear, 2 is divided by 1. Okay, now come to 4. I get to know that 4 can be divided by 2. But remember, if I say 4 can be divided by 2, but remember 2 is also divided by 1. So what it means is 4 is divided by 2. That means anything that divides 2 will also be a part of answer which will divide 4. For example, okay, let me do this here. This is simple maths actually. See, for example, I get to know that, see, 2 is getting divided by 1. Okay, 1 can divide 2. Okay, now I got to know that 4 can be divided by 2. Okay, but that also means, see, because 1 is a part of 2. Okay, that is 1 is a factor of 2, right? So here 1 will also come. Okay, wherever 2 comes, there 1 will also come. If 2 can divide a number, then 1 can also divide that number. Similarly, if I have a 8, okay, let's say I get to know that 4 can divide 8. Okay, 4 can divide 8. What that means, these two will also come that, because any number which 4 can divide, these two can also divide, because they are ultimately factors of 4. Okay, so that 2 and 1 will also come. So that is the basic idea behind which I am going to consider this particular solution. Okay, let me just quickly comment it out. If you want, I can give you this in the comment section. But let's see what the solution is going to be. First thing is very clear. I have already given you that hint. First thing is we will have to sort the answer. Why I am sorting it? Try to understand this fact. If a bigger number tries to divide a smaller number, for example, if I in this case, if I do like 4 divided by 8, I will never get the remainder as 0. Remember that, because 4 is much smaller than 8, so remainder will never come as 0. As simple as that. So the better idea will be to divide the bigger number from the smaller number. Okay, for doing that I will sort the given array. Okay, given nums array, then I will print it out. Okay, what I'm going to notice, I'm going to create a dp array. Okay, so the length of the dp array is also going to be same as the length of the nums array. Okay, and initially all the values will be 1. Okay, all the values will be 1. If you want, I can just quickly print and show this as well. Print dp, yeah, as simple as that. Now I am creating two variables. Okay, so what are the variables? First variable is the max length. Remember, max length, I'm starting with 1 byte. See, max length is basically the length of the largest subset. Okay, satisfying these two given conditions. Okay, so basically whatever is the answer, okay, what is the answer, the length of this particular answer is going to be my max length. Okay, initially I've kept it as 1. Why 1? Can you quickly tell me? See, what can you quickly tell me what will be the minimum possible answer? See, let us say we have all prime numbers here, all prime numbers, that is none will divide the other. So what will the minimum possible answer? Obviously the length of the minimum possible answer is going to be 1, because any one of them can be taken as the answer. As simple as that. Okay, so it will always start with 1. And max index is the last index which comes in our, for example, see here, in this case max index will be the index of the 8. Okay, why? See, try to understand this fact. It is the ending index of our given set. Okay, because I have sorted the array, as you can see, I've sorted the array already. So what will happen is the last index which is part of the our answer set is going to be the max index. Okay, the index of that particular element is going to be the max index. In this case 8 is going to contribute for the max index. Similarly, in this case either 2 or 3 will contribute for the max index. Okay, if different sets are, for example, let us say different answers are possible, different answers of same length are possible, in that case max set, you will see the code now, max index will be the index of one of those you know ending elements. As simple as that. Now this is a kind of a brute force approach which we are going to see now. Okay, but we have a way to optimize it at the same time. Okay, so what is this? I will start I from the index 1 till the last element. For example, in this case I will start from 2 and go till 8. Okay, at the indices of that it will go. Okay, so I will start from 1 and go till end. Okay, and what will be j will always be stopping at 1 index prior to that. Okay, so here, for example, suppose I at this particular index, so j will go around these two indices. Okay, so j will go from 0 till I minus 1. Okay, as you can see. So what I will do, so one thing is very clear. See, all the nums array is already sorted, and what I will do now, I am doing this. Okay, so what will happen is the number pointed by this particular index will always be smaller than the number pointed by this particular index. Remember, the I is going to be from 1 to n minus 1, and j is going to be from 0 to I minus 1. Okay, I hope these things are clear to you. Please note it down somewhere if you are a fresher or if you are not able to understand this kind of solution. This will help you a lot. Okay, these are simple Python syntaxes. I know them because I am continuously using them from years together now. But I understand that if you may not be familiar because you might be new to Python, just write it down initially, and a time will come when you won't have to write it again, and you will be understanding just by seeing it. Okay, so till that stage you will have to write and understand. So next, what I'm checking, I'm just checking if the smaller number can divide the bigger number or not. Okay, as I mentioned, the number pointed by j is the smaller number. The number pointed by I is definitely going to be bigger number because we have sorted the nums. Okay, so if this condition is true, that is the smaller number can divide the bigger number. That is the remainder is 0. What I can conclude, I will now try to use this particular fact. Okay, what is this particular fact? See here, dp of I, dp of I is going to be the max of the dp of I and the dp of j plus 1. Okay, try to understand this fact. Initially all the dp's are 1, right? Now let us try to do this fact. Okay, suppose 1 can divide 2. Okay, 1 can divide 2. The dp of 1 is also 1, the dp of 2 is also 1. So 1 is going to divide 2. That means that is one element is going to be added in our set, right? The probable set. So that is what we are doing in the dp of jc. Dp, what is this dp array? First of all, dp array is going to tell me in the set, in this particular set, how many, that it is the set ending at okay, let me quickly write it here. Okay. Set ending at nums of I. Okay, that is the max length of probable answer set. There is a max length of probable answer set ending at nums of I. Okay, as simple as that. Okay, for example, suppose our answer is going to end at 2, so it will be either 1 comma 2, right? So that is going to be the DP of I. Okay, what I'm doing, whatever is the DP of j, to that I'm adding 1, and I'm making that the making that number as the DP of I. As simple as that. That's what I'm doing here. Okay, because as you can see here, for example, let us say 8 will come, 4 can divide 8, right? That we know, but how many numbers can divide 4, that also will be added to DP of 8. As simple as that. Okay, so that's what I'm doing here. This particular logic is coming from this. Okay, if you have understood this part, I hope you will understand this also. Okay, that's what we are doing here. Then what I will do is, I will just check if, see, dpy is basically the length, right? As I mentioned, these are the lengths. Okay, these are the lengths, and this also is going to track the length. Okay, so I'm just checking if dpy is greater than the max length. Okay, if it is so, I will change the max length equal to dpy. Okay, in that case I will also change max index equal to I. Okay, as simple as that. Finally, I'm doing this print to make to show what we are doing. So it will print in the DP array, it will print in the max length array, and it will print the max index of I. So let me quickly run this and show till this part. Yeah, till this part. Yeah, this is the one. Initially, I can say this is the given DP to us. Okay, as the DP. Yeah, the first is the given array as it is. Okay, after sorting, it will look like this after sorting. Okay, it's already sorted, but in case it is not sorted, it will look like this after sorting. Then this is the initial DP array. All values will be 1, and this is the DP array after our calculations. What it means is, try to understand this fact. DP of 1 is 1 because by default, it's initialized with 1. Okay, as you can see here, it's already 1. Now coming to DP of 2, as you can see, the 2 number can be divided by 1, right? So we'll add the DP of 1 plus 1. That is, this will become 2 now. Okay, similarly coming to 3, 3 can be divided by 1. Okay, so whatever is the DP value of this particular index, add 1 to it. Okay, so in this particular index, add 1 and make it the DP value of this particular index. So it will become 2 again. Okay, now what are these things? Yeah, these are the max length. Okay, what is the max length? Max length is going to be 2. Okay, what is max length basically? Max length is going to be the highest value of dp of I. As simple as that, you can say max length is going to be the highest value of dp of I. As simple as that. Okay, and what is the max index? This is the max index, right? What is the max index? This is the, I have already explained this. Please pause this video, go back and try to understand this fact, because I've already given you a detailed explanation. That's why I'm moving fast now. Okay, so what is the max index? It is pointing to 1. Okay, 0 1 here. What it means is, this is the last index where our try to answer. For example, in this case, max index will point to this particular index. Why? See, in our answer set, whichever is the last element to be added, it will be the index of that element. Okay, so max index of I is the index of the last element to be added in our answer set. As simple as that. In this case, it is pointing to 2. Okay, this particular value it is pointing to, because dp of 3 did not add any new value, because see, dp of 3 is also 2, right? It is not greater than the previous dp value. That's why this value did not change. As simple as that. Okay, so next what we are doing, next, see, remember, we don't have to simply return the length of the highest set. We'll have to return the whole set. For doing that, we have to do another set of calculations. What is that? I'm creating a result array which is going to be returned ultimately. Okay, then what I'm doing, I am taking the nums of max index. Okay, that's what I mentioned. This is going to be the last index to be added in our answer array. From there, we will start and backtrack to get all our elements. Okay, so this is called as number. Okay, now I'm starting from max index. I will go in a reverse way, that is max index minus 1, max index minus 2, like that till I reach 0. Okay, I will go till the 0th index and I will go in the reverse way. These numbers confess that. Okay, this is the Python's way of doing it. Okay, minus 1 means basically we'll go till 0. Similarly, minus 1 means every time the loop will subtract 1 to the rotating index, which is I. Okay, so I will start from this particular index. It every time it will subtract by 1 in each loop, and it will go till 0. Then what I'm doing, I'm just checking if the number, which is this number. Okay, remember, this is the max, this is the biggest number in our probable answer set. Okay, so this, if it is divided by nums of I, what is I? This I. Okay, if it is divided by nums of I in a proper way, and the dp of I, that is the max length ending at that particular index, is equal to max length. Okay, in that case, append that particular number to my answer set. Append that number to my answer set. See why I'm doing like this. Try to understand this fact. As I mentioned, as we saw in this case, okay, for example, 2 and 3 both have the same dp of I value. Okay, both of them have the same dp of I value. So to ensure that nothing unwanted comes into our answer array, we are using these two conditions. First, it should be satisfied, the division should also be there. At the same time, the dp of I also should be equal to max length. Okay, update it here. then reduce the max length by 1, because we are going to go in a reverse way. Okay, I am starting at 2, I will go back to 1. Similarly, I am starting at 8, then I'm going to go to 2. So definitely dp of 4. Okay, I will just quickly run and show you. Actually, the second example I did not show you the dp values. Okay, yeah, as you can see here, these are the final dp values, right? As you can see, the highest value of 8, dp value of this highest value represents the dp value of this particular index. Okay, similarly for 4, the value will decrease by 1. Okay, similarly for 2, this particular 2, the dp value will decrease by 1. Okay, similarly for this particular value, the dp value will decrease by 1. As you can see, the dp values are decreasing when we go from right to left. That's what I'm trying to do here. Okay, so I will subtract 1 from the max index. Okay, and at the same time I will replace the number. Okay, this was the number initially, I will replace it with this particular number, that is the current number of I. Okay, and I will go back, that is let's say I was at 8 now I will go to 4. Okay, and the same thing will again happen. Similarly, the answer will be appended, and finally we return the answer. If I can quickly run this and show you, as you can see, it works, and I've already segmented the solution and it is getting accepted. So yeah, fine. That was this logic. So we are actually kind of using backtracking here, but it's not the usual way of doing a backtracking thing. But after calculating the max length and the size of the data set, we are going back and getting the elements which contributed for this. That is the basic idea. So in a way, yeah, logically it is backtracking. So yeah, fine. That was all for today. I have already given this answer in the uh, the community post here, because I was not able to create this video at that time. It was getting very late, so I did not create the video that time. But I've already given this answer. So please, my advice to you will be: see the questions. I understand you may not be able to get them in a first attempt or something like that. But see, if you keep doing them, believe me, the time will come when this solution will automatically strike to your mind. Okay, you have to come to that stage. And remember, there should not be gaps. For example, if you are growing for 7 days, then you should not leave it for another 7 days. Okay, if you have to do it continuously, then it will benefit. Okay, it's like a compounding kind of interest. Okay, if you have to do, for example, if you contribute every day only, then it will compound. If you break it even 1 day or 2 day, a time will come when you won't feel like doing it again. So that knowledge will not in a way like compound, as simple as that. So I felt this was a very good question. For example, if you are in an interview setup, then yeah, there is a lot to discuss here. Okay, because this question is easy to understand. That is definitely sure. At the same time, there is a lot to discuss. So many concepts are getting involved. There is a concept of DP involved. There is a concept of backtracking getting involved. So definitely there are so many things to trace here, and there are many places where you can make a mistake at the same time. See, the idea of taking these two things may not come to your mind initially. Okay, why we are doing this is because at the time of backtracking, we need to track what are our answers. Okay, for that we need these two things. Okay, so yeah, fine. That was all for today. See, the answer may look very well polished kind of answer, but believe me, to get this answer, there was a lot of attempt behind the scenes, and you will get to know that only if you solve it on your own. That's why purposefully yesterday I did not upload this video. I wanted you to give it a try once, so that if you see my video, it should be in an effective way. Okay, you should be able to understand every bit of it. For that to happen, should have tried this question at least once. You should try answers at least once. Only then you will try to understand where you code is lagging, or which part you are not able to code, what scenario you are not able to code. If you have that in your mind clear, then seeing the solution will help you a lot. So with that, yeah, I am ending this video. If you like my efforts, if you want to get into the same group so that we can continue further doing the questions and setting the answers, then please do consider subscribing to my channel. It really gives a lot of motivation that yeah, our solution is helping someone, and at the same time it motivates us to continue further. It gives us a reason to continue further, as simple as that. So often that was all for today. See you tomorrow. Thanks a lot.